So starting out here, we have magnesium. And you can see it's a metal. It's got a little bit of an oxide coating on here. And so it's got a little bit of a black coating on its surface. But this is magnesium metal. And you'll notice that when we put magnesium into water, we're going to test all their reactivities by dropping the metals in water. A whole bunch of nothing happens. So that's magnesium. I'll leave it sit there. We might come back to it later. The next one we're going to look at then is calcium metal. And calcium metal, you can see here, it's shiny. Again, it's got a little bit of an oxide coating. This stuff's getting a little old. I have to buy some new next year or so. And it's a little bit soft. I mean, I can dent it with the spoon here, but I can't really cut into it all that well. And we take calcium and drop it into water. Should be able to see that it is bubbling quite a bit down there. And the solution here is becoming cloudy. It's becoming hard to see. And that's just because there's so many bubbles in there primarily. There is a little bit of a solid precipitate being formed, I believe. But mostly it's the bubbles. The bubbles you see are a gas being given off, of course. And it turns out that the gas is hydrogen gas. The movement is coming from the gas bubbles that it's giving off, and it's basically like a little motor on it, or rocket on it. You know, it's just the little gas bubbles are pushing it around. There, I'd say we're done finally. There might be a little fleck left there, but just quick, we'll check back in on our magnesium. Still a whole lot of nothing going on. Anyway, our next one is lithium, and I'd like you to see how lithium is stored. And then I'll just point out that all of the others are stored like this. All the rest ones, lithium, sodium, potassium. But I have them stored here in a metal can. And then inside that metal can is a whole bunch of kitty litter, and that's to keep moisture from getting in there. Inside there then is a plastic bag, and that's twist tied shut. And inside there is a bottle. And inside that bottle you'll see a liquid. You can see a liquid in there, and in that liquid you can see floating then some dark bits, and those dark bits are our lithium metal. Get out a new watch glass here. So that's our lithium metal. And it's stored under all those precautions to try to keep it from reacting with the oxygen or water vapor in the air. Now, even so, you'll notice that the lithium is pretty dark in color, covering of oxide on it. But this metal here, you'll notice, I can cut right through with the spoon, the dull edge of a spoon there. And inside, you can see a shiny metal instead of that dull, dark outer surface. And so the reason is because there's that oxide coating on the outside. But we take this and get down another water. Again, the gas being given off is hydrogen gas. I can actually smell it. It's not smoke, it's a water vapor condensing on the hydrogen gas that's being formed. Hydrogen gas is being given off is quite warm. As it rises, it cools, and as it cools, it condenses some of the water vapor out of the air. So it's not actually smoke, but it is a result of the reaction, and it is a gas being given off at least. That piece is almost done, so we'll drop our other chunk in here. That's the lithium. This is your sodium. Again, it's got a dull coating on it, on its outer edge. Sodium, I would say, is even a little softer, a little easier to cut. And again, you'll notice that it is very shiny for a metal. But I want you to note that I'm cutting metals here with a spoon. I mean, I can probably squeeze really hard and squeeze through this sodium pretty easily. But we'll shrink the size of that down just a little bit. And then we'll drop a piece of, we'll do that one. This into the water. You'll notice immediately that it turns into a spherical shape. It's actually molten. Oh, crap. And you can see why I stepped away. We'll try again here with the sodium metal. Now, it doesn't always catch on fire like it did there, but you can see it's got it's turned molten, and because it's molten, it forms that ball shape. It's actually a molten metal there on the surface. There we have the fire. The fire is what color, by the way? Orange. It's an orange flame. And you're like, all fires are kind of yellow-orange, but the next one, we might notice a different color. Doesn't always pop. Got one more small piece here. We'll do about the same size as the last two. There's the fire again. But you'll notice obviously more reactive than lithium, more reactive than the alkali metals that we took a look at. Anyway, one last one to show you, and that is potassium. Anyway, there's potassium. And again, just to show you, it is a soft metal. I can cut it with a knife or with a spoon. In fact, I cut it and accidentally flipped it off the watch glass there, but there we can cut it with a spoon. And we need to get down or use our last beaker of water here. So here we go, and gotta scrape it in. Color of the flame? Kind of purpley color. Lavender color is usually how it's described. But it is actually a colored flame there that you're seeing. Much faster reaction, and so yes, it caught on fire, and it didn't pop like the sodium there did, but you'll notice it was a fairly fast reaction, and that's again because it's more reactive, and more reactive means not only kind of the violence of the reaction, but also refers to somewhat to the speed of the reaction, and so you'll notice there's a much faster reaction here. Here as a demonstration. Real quick, one last time, we'll check in on our magnesium. Remember our magnesium we did way at the beginning? If you look really closely on the magnesium, you'll notice it's floating now. And because it's floating now, that means that it's somehow become less than the water. And the fact is there's some bubbles on here. They're very tiny bubbles. And there I shook most of them. So it reacts just very slowly.